Welcome to solverfy.
Okay, this question wants us to approximate this integral using the trapezoid rule and compare that to the actual result. So, it wants us to use the trapezoid rule with n equal to 10, which says that area is approximately delta x over 2 times f of the starting point plus 2 times the middle values plus f of the other endpoint. Because again, we're double counting the areas in the middle during this approximation. So, doing this, we see that area is approximately, well, what is delta x? So, let's do a little aside here. Delta x equals 20 minus 0 over 10, which is equal to 2. So it's equal to 2 over 2, so we're not even going to write anything. F of 0 plus f of 2 plus, 2f of 2 plus 2f of 4 plus all the way up to f of 20. So, if we do this, we see that our area equals 1 plus 2 plus 2 plus 2 plus 1, based on this formula. So, we have 9 2's in the middle plus 2 from the end. So, we get that area is approximately equal to 20 by the trapezoid rule. But now let's see what the actual result is. Integral from 0 to 20 of cosine of pi x dx is, well, the antiderivative of cosine is sine, and then we have to divide by the Chen-Lu factor of pi. We're evaluating that from 0 to 20, and that's just 1 over pi times sine of 20 pi minus sine of 0, and both of these are 0, so it says the real area is 0. So why is there a discrepancy here? Well, here's what's happening if we look at our graph. So cosine of pi x is going to look something like this. Actually, I'll draw a bigger period, or smaller period, so we can really see what's going on here. So, with our trapezoids, basically, we're only hitting the positive portions of this graph. Because our subintervals are too big. So we're only hitting these positive peaks, so we're missing all this negative portion. So for example, the area of cosine of pi x over these periods, if we just want the absolute value of cosine x, it should be 40. Because we're only retrieving half the area here. We're just not taking into account the negatives. So, since delta x is too large, we miss all of the negative area. So that's a danger of approximation. You have to make sure your delta x is small enough to catch sensitivities like that in the graph.